Welcome to my YouTube channel Rezaka. Today we will see for the electric dipole what is the potential. Okay. So for the electric dipole, how the potential term is defined. Okay. So firstly we will see what is the potential energy. Okay. So the potential energy is nothing else but the mutual energy of two charged particles. Okay. So suppose that there are two charged particles Q1 and Q2. Both are having a positive sign, and the distance between these two particles is r. Okay. So the potential energy will be Q1 Q2 upon 4 pi epsilon naught r. Okay. How this term came? Okay. So U is equal to Q1 Q2 upon 4 pi epsilon naught r. Okay. So how this term U is equal to 4 pi epsilon naught r came? Okay. So we know that the work done is equal to force into displacement. Okay. And the force for these two particles is Q1 Q2 upon 4 pi epsilon naught r square. Okay. So this is the force, and what is the distance? Distance is r. Okay. So r and r gets cancelled. Okay. So this the work done will be this. Okay. So work done is equal to the potential energy between the two particles. Okay. So this now came out to be Q1 Q2 upon 4 pi epsilon naught r. Okay. So suppose that for more understanding how this explanation is given, suppose that this is the particle Q1. Okay. This is at infinity. Firstly, this particle was at an infinite distance, this particle Q1. So how much work we will have to do to bring this particle from an infinite distance to this? Okay. So the work done is equal to nothing else but equal to work done equals to change in potential energy. Okay. Change in potential energy. Work done is equal to change in potential energy. So when the particle Q1 was at the infinite distance, the potential energy U1 was equal to 0. Okay. And when the particle came out here, the potential energy will be Q1 Q2 upon 4 pi epsilon naught r. Okay. So work done will be Q1 Q2 upon 4 pi epsilon naught r. So from this also we can deduce that it is correct or not. Okay. So work done equals to change in potential energy. Firstly, the particle was at an infinite distance, so the potential energy was 0. But when it came out at a distance of r with in front of this particle Q2, the potential energy came out to be Q1 Q2 upon 4 pi epsilon naught r. So the work done is equal to Q1 Q2 upon 4 pi epsilon naught r, or the mutual potential energy is equal to Q1 Q2 upon 4 pi epsilon naught r. Okay. So like this we can see. Okay. So let's see in the case of electric dipole how the things change. Okay. So suppose that this is an electric dipole. Okay. Topic of electric dipole. Okay. Suppose that this is an electric dipole having charge positive and having charge negative. Okay. So and this plane, whole plane, we can see that the distance from here, suppose that this is an electric dipole whose distance is r. Okay. The distance between these two particles, this positive charge and negative charge of the electric dipole, which is of distance r, or we can say that the length of the dipole is L. Okay. Which is of length L is there, and there is a plane. So the plane, this distance and this distance will be equal. Okay. So the electric potential because of this will be Q upon 4 pi epsilon naught r, but because of this negative charge, the electric potential will be minus Q upon 4 pi epsilon naught r. So these two terms will be cancelled and the electric potential will be 0. This will be not be r, this will be this will be like this. Okay, so x under root x square plus L by 2 square. This r will be like this. Okay, so this is r. Okay, we are saying this is r. Okay, so r will be under root x square plus L by 2 square. So the value of the electric potential in this plane, which is dividing this electric dipole, will be equal to 0. Electric potential will be 0 if we move this distance. Okay, so if we move towards the positive charge, okay, if we move towards the positive charge, what will happen? This capital R will increase. This capital R will increase. Okay, so this will decrease. Okay, so now what will happen if we change our distance? Okay, if we move here and here, what will be the electric potential of the electric dipole? Okay, so if it is asked in any question, what is the electric potential in the about the plane which is dividing the electric dipole of length L, the potential will be 0. Now we will see what will be the electric potential in the electric dipole in the different position of the electric dipole. Okay, so suppose that there is a position of in the electric dipole. Suppose that this is the electric dipole of length L. Okay, and this is like this. Okay, so suppose that we are in this point. Okay, this point. So what will happen? This distance is R1 and this distance is R2. So R1 is less than R2. So the electric potential because of this positive charge will be Q upon 4 pi epsilon naught R1, and because of this R2, this will be Q upon 4 pi epsilon naught R2. Okay, so since the R1 is less, okay, so this will be more and this will be less. So here the electric potential will be positive. Okay, so in this whole region which is on the left side of this positive charge, the electric potential will be positive, and it is opposite. So in the whole distance where here the electric potential will be negative. Okay, so we can also deduce by like the electric potential because of positive will be Q upon 4 pi epsilon naught R1. Because of negative, the electric potential will be Q upon 4 pi epsilon naught R2. Since this small R1 now will be greater and then R2. Okay, so this R2 is smaller, so this quantity will be more. Okay, and this quantity will be less. Okay, since R1 is more, so in total this is negative. So in total the sign will be negative of the electric potential. So this is how we can see what are the values of electric potential at different places or different points in a plane in an electric dipole. Only at the plane which is bisecting this dipole of length L, the electric potential is 0. In the left hand side the electric potential is positive. In the right hand side the electric potential is negative. So this is how we will deduce what is the value of or what is the sign of the electric potential. If we have to find the value, so this how we will find the value of the electric potential in the particular point in an electric dipole. So suppose that there, let's take one example to calculate the value. How we will solve the question if the value of the electric potential at a particular point is asked. So if the values are asked at the bisection, so it will be 0 only. Okay, but if it is asked at different place, so how we will find? Okay, so suppose that there is a point which is at this distance which is 2, okay, 2 meter. Okay, and from the negative charge it is 4 meter. Okay, so we can see that the electric potential here because of this charge Q upon 4 pi epsilon naught 2, and because of this the value will be Q upon 4 pi epsilon naught 4. Okay, this will be in the minus sign. Okay, and 1 upon 4 pi epsilon naught is nothing else but K. We take here it as K. Okay, so if the value of suppose that K is given as 10. Okay, so suppose that this is a hypothetical value. Suppose that the value of k is 10. Okay, so like this only the value will be given. So 1 upon 4 pi epsilon naught value will be given as k, and it will be a some value. Okay, so we can also find this value. Epsilon naught value is some about 8.85 into 10 to the minus 12 like this, and we will put the value of 4 and pi. So like this is some value. Okay, so we will get the 1 upon 4 pi epsilon naught value. So suppose that this value of is 10. Okay, and the value of q is given as 2 coulomb. Okay, so what will the value? 2 into 10 into 1 by 2, which is 10. Here it came out to be 10, and what will be here? 2 into 10 into 1 by 4. Okay, so it will be 5. Okay, so what will be the net value? 10 minus 5. Okay, so electric potential will be 5 volt. Okay, so like this we can find what will be the value of the electric potential at different place in an electric dipole. Okay, so let's see some more things in the electric dipole. Okay, so suppose that this is an electric dipole. Okay, and suppose that there is one more geometry which is like this. This whole thing is positive in sign. This is a ring. Okay, this is a ring. This whole left hand side is of positive sign, and this whole ring, this is of negative sign. So the what concepts we have learned in the electric dipole, this is not an electric dipole, but the geometry is like an electric dipole. So what will be the things if the question is asked like this? Various questions in the previous seasons are asked. So if the question like this is asked, so what will be there? So how, in what places the electric potential will be 0 in this ring? So the electric potential will be 0 in the line which is passing through the center. Okay, the line which will be passing through the center of this ring like this will be 0. So suppose that all positive charge will give their positive potential in this place, and all negative charges will give their negative potential in this place. So it will cancel, and if we come out, the radius will be the length will be same. So suppose that this negative sign, the length is same, and because of this positive, the length is also same. So if we move in the inside the plane of, or if we go outside the plane, or in all the places, the electric potential will be 0. So in all points on the line passing through center, value of potential is 0. Okay, so the value of the potential in all the points will be 0. So there is a positively charged ring which is on the left hand side, and the negatively charged ring is on the right hand side. Okay, so the electric potential on the line passing through the center will be equal to 0. So this is very important question which can be asked. Okay, so like this we can solve what is the value of the electric potential and on the different places. Okay, so now I have also told you in the previous minute that the value of the electric potential is found. Value of electric potential is nothing else but the work done. Okay, so the value of work done is nothing else but the electric potential. Okay, or the potential difference. So this is a very important thing which we have to remember. Okay. So suppose that there is the charge assembly which is like this. Okay, of Q1 and Q2, and what will be the work done? Work done will be nothing else but the change in potential energy. So we will bring the charge always from the infinite, and what will be the electric potential here will be Q1 Q2 upon 4 pi epsilon naught R. So work done will be Q1 Q2 upon 4 pi epsilon naught R. So change in potential energy, initially it was 0, finally it was this. Okay, so final minus initial. Okay, so this is the electric potential which is there. Okay, and this is equal to the work done which will be there. Okay, so like this we will solve the question. Okay, what is the work done? Work done is nothing else but the change in potential energy in forming this assembly. Okay, this is an assembly. Okay, so like this language only the question will be asked. Okay, so suppose that there is one question like this. There is this positively charged ring. Okay, whole ring is positively charged. Okay, whole ring is positively charged. So we have to tell what is the work done in forming this ring. So suppose that firstly the ring was this, no charge was there, but finally we made the ring this. Okay, so what is the work done in forming this ring? Work done in forming a positively charged ring. Okay, so what is the work done in forming this positively charged ring? Okay, so as I have told, in forming this assembly of positively charged ring, the work done is equal to the change in potential energy. Okay, so firstly when it was like this, the potential energy was equal to 0. Finally the potential energy is nothing else but, suppose that this is whole charge which is distributed uniformly is of charge Q, this whole charge. Okay, not this whole charge is of Q coulombs. Okay, Q whole charge value is Q. Okay, so what will be the potential energy? Potential energy, it will be Q upon 4 pi epsilon naught R. Okay, because from the center it is at a distance of R. Okay, so the work done in forming this ring will be nothing else but equal to change in potential energy which will be Q upon 4 pi epsilon naught R. So the work done in forming this ring will be this one. Okay, so like this we will solve the question. Okay, so what is the work done in forming this ring will be equal to the change in potential energy. Okay, so suppose that there is another question in which we will be solving. Okay, so suppose that there is a particular ring in which there is a positive sign here, positively charged, and here it is negatively charged. Okay, so what is the work done in forming this ring? So initially as the ring was having no charge, so work done will be equal to 0. Then suppose that only this here this positive charge was there. Okay, so firstly we put the positive charge. Okay, and then we put at the negative charge. Okay, so if we see, for forming this positive charge, suppose that this is of sign Q by 2 and this is also of Q by 2. So because of this Q by 2, the potential energy change will be Q by 2 upon 4 pi epsilon naught R. And because of this negatively charged, minus Q by 2 upon 4 pi epsilon naught R. Okay, so total change in potential energy will be equal to 0. So work done will be equal to 0. Okay, so like this we will tell what is the work done in forming this ring which is half of q by 2 and another half of minus q by 2. Okay, so the work done will be equal to 0 because the change in potential energy is 0. Okay, so like this we will tell. Okay, thank you.